Welcome back to another episode of Data Science at Home podcast. I'm Francesco, podcasting from the Brussels office in Belgium. Ametix Technologies is our sponsor today. And today, as you can see, I'm not alone. I am, those who can see, of course, are on YouTube. The listeners of the podcast are very much invited to hit the YouTube channel. It's a new one, youtube.com/@datascienceathome. Of course, you will find links in the show notes of this episode, as well as the official website, datascienceathome.com. As I was saying, I'm not alone. Today, I'm spending a very interesting time with Kenny Vaneetvelde. I hope that after 15 years in Belgium, I can pronounce his family name. Hi, Kenny. How are you doing today?
I'm good. How are you? Thanks for having me.
It's a pleasure. And in fact, I'm very intrigued by this episode because, first of all, we have been planning this episode for quite some time now, but there is, Kenny is working on something that is extremely important, and in my opinion, and definitely his own opinion as well, it's going to be kind of the future of AI. So today we're going to discuss about agentic AI, which is one of these super hot topics these days. But in my opinion, is the one of the few possibilities for what we call artificial intelligence to move a step forward with respect to what normal or traditional, we can say now, large language models can do. So with agentic AI, in fact, large language models have already become traditional things or classic things. We're already one step ahead.
That went quick.
Is that right? Is that right, Kenny?
Exactly.
Well, so I think we better start by introducing ourselves. Well, you need to introduce yourself to the listeners of the podcast. So take the stage, please. Take it away.
So I'm Kenny. I've been coding for a long time. Started when I was about 13. I also got into machine learning and AI around the age of 16. It was around the time that deep learning first became practically feasible. Career-wise, mostly I've always done consultancy, but different roles, different companies, different technologies. So I've done small companies, big companies, government. I've done back-end, front-end, some data engineering. I've spent a lot of time improving developer experience by writing custom tools. I just do whatever is interesting. And yeah, since I already had a big fascination with AI, and now LLMs came along, I decided let's shift my career towards AI because this is very fun, and I already saw a lot of potential. Of course, everybody did, but yeah, just taking bits and pieces of existing processes and using AI there and just optimizing everything.
Mm-hmm.
And I decided to do this together with a colleague under the moniker of BrainBlend AI. And to do this, of course, we needed to write tools because it's only just two people. And if we are going to be delivering, projects, and if we're gonna, especially if you want to get bigger companies on our own, I decided I will need some tools that can really help me iterate fast and deliver something that's not only just a proof of concept, of course, but also can be, built into something that can be put into production.
Right.
And yeah, so that's I tried out a lot of things, wasn't really happy. That's how I made my framework.
And indeed, we're going to talk about that because the main topic of the day is going to be about one thing that is called atomic agents, which I think I recently checked. It was like 1,300 stars on GitHub, right? Something like that.
Almost,
It's
exactly.
not bad at all for a very new project, definitely. And also given the let's say competition, even though when we speak about open source software, speaking about competition is a bit of a big deal. But there are other tools, of course. So we're gonna talk about that extensively during this episode. So, what does Atomic Agent do for those who are, not really familiar with large language models? I know there are not so many anymore who are not familiar with large language models now, but let's give it a shot.
So the way I always try to explain it is, a large language model, you can really simplify it. It's input, you do something with the input, and you get something back, right? That input can be anything, of course, as long as it's text, some kind of language, and the output can be anything. So what if you start to encapsulate like small problems? For example, a web search, you break it down into steps that you usually would do as a person. So first you need to generate a search query. You do this in your mind, you think of a query, you put in the query, then you see something, that's another input, right? You have text, and you do something with that text, and then in the end you can answer a question. And so all those small blocks, like generating a query, answering a question based on text, stuff like that, you can just think of those as Lego blocks, and then you can just start piecing them together in different
Yeah.
ways. If you are not happy with the way the query is generated, you can simply change that without affecting the entire system. Because similarly to Lego blocks, because Lego blocks, they always have like the same connections, right?
Yeah.
And very, very analogous to that. Every agent and every tool within Atomic Agents has that same connection with
So
everything.
it's essentially a mix and match of basic capabilities that you can compose in a very creative way in order to get more and more sophisticated behaviors. And that, I mentioned this at the beginning of this episode. It's going to be kind of, in my opinion, personally, the future of AI. Like there, it's very unlikely that it's going to be a massive large language model that can solve anything. It's much more likely there will be a lot more or many smaller models specialized in something, and then we need some framework, and here comes atomic agents to combine these things and build a complex behavior that is closer and closer to human capabilities. So that's pretty much what it is. Now we have another 30 minutes of episode, so we're gonna definitely explore this high level definition of atomic agents or agents, AI agents, and also have a look more closely to what Kenny what you built, in fact, with atomic agents. Now, you have emphasized atomicity in the framework. Um, why is it crucial in AI development today? And I say today because we don't know what's going to happen in like a few months from now. Everybody seems to have some kind of bunny out of the hat.
Yeah, exactly. Surprises keep happening even after 2 years. No, but so atomicity is it's not just an AI. It's really a generic, very important concept in software development in general. It's just getting into the habit of breaking down a problem into its smallest components. And I think a big contrast is so some other ways of thinking about agents that are common are like, oh, we have a researcher agent, an editor agent, we have a team manager agent. And in practice, those things don't really work. Plus, you have no control. If you're implementing this, or if you're a company, using these systems, you want as much control as possible. That's feedback that I keep getting from people in companies, right? And yeah, so what you want to do is you want to break down how does that research happen, and then you can start really thinking about, okay, what's the flow that we're going to implement here, and where can we use AI to get
Mm.
the best results out of this.
Right.
And yeah, that's where I put atomicity into AI, where I kind of built
Okay.
that bridge.
It's like a first-class citizen. It's also true that atomicity, from a software engineering perspective, it's a principle. In fact, it allows you to think better about the problem. At least that worked with me, and also makes the outcome, your product, your artifact, whatever that is, a lot more flexible. Because if it's like factorizing things since day one.
Yes, 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 exactly.
Okay. Kenny, let's dive into the framework a bit, because now I guess people are curious to know a bit more about that. So I would ask you, I would start from the fact that the AI space is, we know it's packed with frameworks now, and there are more and more that come out. Probably we don't even know. And all of them, each of them is actually saying that it's going to revolutionize something or everything for those who are even more ambitious than that. So my question to you is like, what makes atomic agents truly stand out? What gaps does it fill that other frameworks are missing?
Yeah, I usually say kind of the opposite. I'm not gonna really revolutionize much. I'm gonna try and bring it back to. I always try to bring it back as close to traditional development as possible,
Right.
because that's. I mean, personally, I see, you can see some really cool demos on YouTube, some really like, wow, an agent that builds like an entire snake game from scratch. Uh, that's great, but 2 points, like, one, snake games are all over the internet, so it's probably a very popular thing in the training data. Of course, it's flashy, so, and a lot of people don't really understand that part. They just see, oh, an entire game from scratch. But secondly, also nobody is waiting for something like that, right? Because you can say, okay, give me a snake game, but then, okay, but what does it have to look like? Like,
Right.
does it, where does the score go? Does it go in the top left? And in practice, people have very strong opinions on what their products or features should look like, should be like, and more they just really want control and planning, and that's just a hole that frameworks like, for example, CrewAI and AutoGen really don't fill.
Right.
They are much more focused on complete autonomy and like autonomous multi-agent systems. Whereas
Okay.
I say, it's and the feedback that I keep getting from CTOs and stuff is, we want to have that control. We want to be able to define how the research should happen, because we do it in a very specific way using very specific systems that have a very particular way of working that is very different from building a snake game from a single
Right.
prompt.
That was a common problem that we also found when there were claims about artificial intelligence or large language models knowing how to code. And what we found in some benchmarks is that, of course, they know how to code, quote unquote, on SQL and not on many other languages. Like the hallucinations that you get from less common languages, of course, in the training set. So that's pretty much the concept of this. These claims, you always have to, not you, of course, you do know, but you listeners and everybody, we have to definitely take into account the training set. So in which aspect of the world is that large language model actually good at solving things? So don't get fooled by claims, like that. Kenny, you have mentioned that atomic agents eliminates redundant complexity and hidden assumptions. I think I read that also from the README or somewhere on your blogs. By the way, we're gonna report all of your links or most of the
Yes.
interesting links in the show notes of this episode, so people can even try, or definitely try, or even collaborate if they want. Now, can you give me an example of what that looks like in practical use cases? Redundant complexity and hidden assumptions.
Yeah.
What's that?
There are a bit vague terms that I've since, I think, removed from the README. But
Okay.
what it meant mostly, so that's the other big competitor that we can talk about is LangChain, of course.
Hmm.
And really, to anybody who has seriously developed something with LangChain, I haven't heard much like long-term maintenance, a lot of good things about it. So that's mostly they have a for every way to do RAG, for example, so retrieval augmented generation, where you use resources like your documents to answer questions or use the web to answer questions. There's a lot of different ways to do that. And for example, whenever a new paper came out, they would implement that way. Great, but in terms of maintenance, it quickly got outdated. Whereas they were techniques that you could just simply implement really in 5 minutes. And so what LangChain did was taking a lot of things that you could actually do in 5 minutes, wrapped around that, and actually made it more difficult and less maintainable. And everywhere you go look, Reddit, wherever, the common complaint is always the documentation is out of date. There's 5 ways to do something and none of them work. Yeah, so
It's a terrible tool, basically. I mean, that's the nightmare for a software engineer.
it's for a serious software engineer, indeed, it's a bit of a nightmare. And so, yes, I tried my very best to make something that would not have all those issues by just keeping it much more simple. I don't want to give you an integration with every possible vector database. I don't want to give you an integration with every possible search engine, because I built it for developers and I try to give you the tools that enable you to build it yourself in 5 minutes.
Exactly.
And you can build it your way to your exact specifications. And if you want to change those, you have full ownership.
Right. That's I mean, it's indeed refactorizing things and think in modular ways, so that it's a developer tool made by a developer for developers. So of course it has to have some kind, it has to
Yes.
have it has to be extremely flexible, because otherwise, and extremely well documented. Is there documentation in Atomic Agents?
Yes, I use just common docstring conventions for everything, which means I can automatically generate documentation, of course.
Right.
But also I try to provide a lot of examples.
Okay.
I have some examples right there inside of the repository. I have some examples that I do Medium articles on, and that I also have in separate repositories on my personal account. So.
Nice. No, I actually appreciate the fact that you tried LangChain and probably other tools. I also tried LangChain, and I definitely was not happy. I can definitely confirm part of what
It's
you said.
great. You can prototype stuff with it very quickly, and
Yeah.
that was the initial attraction. Like you can in like 10 minutes like create something real
A
quickly
sketch,
that's
right.
kind of like flashy, and you can use it to start to convince some of the higher ups, like, hey, let's build something with AI. But then the feedback that I get from people that try to put it into production is
Yeah,
just that, like, yeah, it's not production
it's a
ready.
different story. No, I was saying I appreciate that because a developer who tried other tools and got annoyed and then builds a tool that does exactly the same thing, unless he's a psychopath, he will definitely avoid the things he was annoyed by. so,
Exactly.
there is already one step forward into how the thing should have been done, and it was not. That's why you did it, and it should be doing that, right? Okay, I guess that the tech people are definitely following us today. So I'm gonna dive deeper into the technical talk, because I want to ask you about the technologies that you have built atomic agents on top. For example, there is Instructor, there is Pydantic for validation. Pydantic is that the nice thing, is the thing that makes Python nice, because it takes care of types, or tries to.
Exactly.
Now, what are the advantages that these tools bring to the table? And Kenny, feel free to be technical. The listeners of this show is a mixed audience, of course, but we have a lot of nerds on board.
Yes, yes. So yeah, Instructor basically just makes sure that the LLM will adhere to a certain Pydantic schema. And so a Pydantic schema is just saying, like, oh, let's say you have a contract and you want to extract parties from that. You as a developer will need to define some way, like, what is a party? A party is an entity with a name, a last name, an address, stuff like that.
Mhm.
And it gives you, so Pydantic is nothing new. It has been in use in APIs before, where it's used to do exactly that, define a schema for an API to adhere to. And so it's the same principle, but with AI. So we tell GPT or whatever model, like, here's a contract. Now you need to extract a list of parties, and a party is a name, last name, address, and so forth. And Instructor is basically a library around it that allows you to use Pydantic in that way. But also, what Instructor does is it provides a single, easy way to use different providers and different models. So, if you want, you can pretty easily switch from OpenAI to Grok or Anthropic or local if that's what you
Right.
want. Yep, that's basically
Okay.
Instructor and Pydantic.
And Pydantic. Okay.
One caveat is that that's pretty new still. Pydantic AI just came out.
Okay.
And so I am looking, maybe in the future we might replace Instructor with Pydantic AI. But it's going to depend a little bit, because today Instructor does have support for multiple languages. And
Okay.
today, Atomic Agents is only in Python, but maybe if we want to. So it's going to depend. If we stay with just Python, we might ditch Instructor and go with Pydantic AI.
Right.
Yeah.
Makes sense. Just curiosity, have you ever thought of Rust for such things?
Yeah, exactly. So that's part of the reasons. So I think Instructor is available in Rust. So it would be really nice if Atomic Agents was just available like that in Rust.
Yeah. It would not help, in my opinion, that much on the performance, even though they would definitely add, because these are,
No,
agents are, there might be a huge lag, which is the network probably in between two modules, let's say. So you might not, end to end, you might not experience big performance impacts, but in terms of maintenance and maintainability of the code, maybe that could
exactly.
help a lot. Okay, that's cool. Kenny, the monorepo structure, I want to talk about that, because if you go on the on the GitHub. There is this structure. I have to say it's very well organized. I skimmed a bit your code. I've been writing Python for a long time, but now my new world is Rust, of course. But I still remember Python, and I have to say that it's really well written. I could feel that modularity in mind by reading your code. So it's very nice to read. So there are these macro
Thank you.
blocks. No worries. These macro blocks like atomic agents, the assembler, examples, of course, which are amazing because they work. There is Atomic Forge. Now, this organization is, of course, what you chose, and that's fine. How or does this structure make it easier for contributors to jump in eventually? Is there a learning curve? Is there things they might be ignoring at the beginning? What is your suggestion on that?
Well, I'm of the opinion that it makes everything easier. Not necessarily just by the fact that it's a monorepo, but also by the way a little that it's set up. So maybe a bit of an overview first. So indeed, we have the core library, we have examples, and then we have atomic assembler, which we haven't talked yet about, but it's a CLI tool that I made to. We have, for example, a search tool that uses circs-ng search provider. So you can easily just get that. And instead of putting it into the core library, so if you pip install the core library, you don't get those tools out of the box. Main reason for that is bloat. So if we tomorrow have 100 of those tools, each of those tools, for example, I have a YouTube transcript scraper tool that uses the YouTube package. We have the circs-ng that uses other packages. If you have 100 of those tools, your hello world is going to be a gigabyte big, and we don't want that. But I still wanted to keep it all together for when you're looking at it, so that's why it's still in the same repository.
Okay.
But the examples, they all, so they are linked to the core library in such a way that if you install the examples and if you were to debug them, if you were running them, going through them, debugging them, then the actual dependency on atomic agents is within the repository itself. So you could step into the core library that way, and I think that's very inviting to developers because it's just like by going through the examples, you're also getting familiar with the core library if you want.
Nice. Kenny, I think it's time. It's just the right time to show off a bit, if I can say that. So, no, the reason of this video, and of course, we chose the YouTube channel to make it more convenient because it would be nice to see these things in action. So, Kenny, please, if you have prepared something for us, we are very happy to watch.
Just a second. Yes, there we go.
Nice.
So let's first, I'm already running it, but let's first go through what this example is. So it's a deep research chat agent. It's one of the examples that's in the repository as well. And what this example does is you can chat with it, obviously. And whenever you send a message, it's going to decide, do I need to do a web search or not? And yeah, so at the start, it just says, I can help you explore and understand topics. It gives you some example questions. Mm-hmm. We can take an example question here. And I'll take you through exactly how this works in a second, but yeah. So we already, I think everybody in the AI community already knows this one. But here you can see also the internal reasoning. So the question asks for the winner of the Nobel Prize in Physics for the current year, 2024. My training data only goes up to October 2023. So, I need to do a search. It will generate 3 queries because that's how I set it up. I take these queries. I'll explain in a second, but I take these queries and in the end, search, scrape some web data, then give an answer. And the answer in this case is that the Nobel Prize went to Hopfield and Geoffrey Hinton. So yes, and then we are presented with some follow-up questions. And I could now ask, I can't really type anything, but I'm just copy-pasting these questions now because that's easier.
Yeah.
And here it has decided. So I asked what specific discoveries led to the Nobel Prize. And here it decided to use the existing context. So it didn't do a new web search. Why? It already did a web search before. It already has information that it didn't necessarily have in the answer, but it had more information than it presented me with. And now it's reusing that information to answer my follow-up question. So here it tells me about the work in machine learning, artificial neural networks.
Where is that information stored, in fact?
I can go over that in a second. It will all become clear. It will become clear. So yes, and again, we have some follow-up questions. Now I can maybe ask, how about the Nobel in chemistry? And now it knows like, oh, I only have information about the Nobel Prize in physics. I don't have anything yet about the Nobel Prize in chemistry. So I'm going to do a new search. And here we are with the information about the Nobel Prize in chemistry. So as to your question, maybe it will be most useful to first look at this schema. It's a bit high level, but let's see. Can I? No. Okay. So basically, the flow is we have a question, we decide if it needs a search. If yes, we generate queries, perform a web search, scrape web pages, update the context, and generate an answer. If no, we just generate an answer, show the answer and follow up. That's what we just saw.
Mm-hmm.
How does it do this? This is a bit of a messy schema. I will go through the code as well, but just to already get a bit of an idea. So we have context providers. That's where it stores information. Information can be the current date. That's how it knew that the current date was 2024 and that it only had information up to 2023.
Right.
And the scraped content, that's also a context provider. Those context providers get populated through traditional codes. Like as a developer, you say like, okay, now you need to put this information in here. And then, of course, that can come from tools. And we then have the agents. So in this case, we actually had 3 agents. As a user, we were talking to the choice agent.
Yeah.
No, actually, we were talking to the choice agent. Choice agent made the decision, then it went to the query agent, the answer agent, back to the user. Okay. So in code, what would that look like? An agent, as I said, at the start of the podcast. Maybe
A bit bigger
that's
font,
a
yeah.
bit small. Maybe
Yeah, it
you want me to
a
make
bit
it
more.
bigger? Bigger?
Yeah, just a bit. There you
Yeah,
go.
like that.
Thank you.
Okay,
I'm
great.
myopic here.
So yes. So like I said at the start of the podcast, every agent and every tool has the same structure. So we always have an input schema. In this case, a user message and decision type. This is a Pydantic schema. We Every field has a description. Both the docstring and this description get passed to the LLM. So there's also the main benefit of this is if you're a developer, right? You get a ticket, and the bug ticket says this specific bit of information isn't always extracted properly from the document. As a developer, I can now go, so okay, I'm in the party schema, and oh, the last name isn't always extracted properly, so I can go here and I can say, oh, this is exactly how you will find it, and you can just start modifying. Yeah,
Right.
so this is basically prompt engineering, but much more targeted, much more targeted.
Gotcha.
And so each agent has its input schema, output schema, and then alongside that, you also have more what you would consider to be just a classic system prompt.
Yeah.
Here I took a lot of inspiration from a tool called Fabric by Daniel Miesler, which is a command line tool that allows you to use LLMs in command line. And every agent there, if you can call it an agent, I guess you can, is defined in this way. So you always have a background, steps like how you do this, then that. I number them here. And then some output instructions, which would be more like how do you want the tone of voice to be of the agent? Do you want it to be very friendly? Do you want it to be?
Right.
So it allows you to fine tune that a bit more. And then I like to have some usage example here. And then you can also, of course, run this on its own if you want, which also is very easy for you as a developer because you want to be able to test everything
Immediately.
in isolation immediately. You want to be sure that this is correct before you plug it into the system.
Right.
And so in the same way, we have a QA agent, so question answering agent, takes in a question, gives an answer, and follow-up questions. And so, of course, this question answering agent, it needs the context. And for that, we have the context providers. And so you see here a context provider, also, again, the same structure, which as a developer, I think that's very important. That's also like a big problem in companies that you see, and also a common complaint that I heard about other frameworks. And even if you don't use a framework and you have a team of developers, a big problem is always like, okay, he does it his way, does it his way, and everybody is just doing their own thing, and we don't really have code guidelines yet.
Yeah.
Atomic Agents kind of tries to provide you with implicit code guidelines out of the box. It's just, here's how you do it. You always have a class. It always inherits from this. You always have a get info, and you have your formatting in here. Aside from that, you can have whatever you want, but this is what you need. And so the current date context provider has a get info that just returns a string, the current date, and this format is this date. And for your web sources, you have the same thing. We have a list of content items, which content and URL. And we have a way to format those content items. And then you have a main file that kind of just ties it all together. This is not just have a welcome message, starter questions, perform search and update context. So let's just take you through the main flow. The very first thing you do is you initialize the context providers, and then you can start assigning them to agents. It's your choice. In this case, I have basically assigned every context provider to every agent. But you could say it's not really of any use that the query agent knows what date it is. I found it to be useful, so I do include it. But that's your choice, really, and it's as easy as just having it or not having it. Very plug and play,
Right.
in that way. You take your user input, you then put it into the first agent. So you just run the agent with the input schema. As a developer, you also here have your auto-completion and your IntelliSense and all that good stuff. So you see it needs a user message and a decision type. So we have the user message, we have the decision type. Decision type is just because I wanted this choice agent to be kind of generic and reusable.
Right.
So I tell it here, like, should we perform a new web search? True if, so I give it some information. And then we do that. So display search status. So we have decided if we needed a new search. We have the reasoning behind that. Also, maybe it's useful to touch on this. So a familiar term maybe might be, the whole chain of thought and stuff like that.
I was saying that, yeah. It looks a lot more, yeah.
So one of the things that I often do is, so my agent might start out without this reasoning, and I might find that it kind of underperforms. And very often I find that my improvement of my agents just improves if I just add this. And simply by doing this, and also because the order is respected, so it will always do the reasoning first before outputting a decision, which by virtue of having done the reasoning will improve the output of the decision.
Right.
So that's a little benefit or a little thing that you can very easily implement. And here I just print that. And then because we now have a decision that's been made, it's just a Boolean. We can now just use that in an if-else, right?
Yeah.
So here we just have that available in traditional code. And now we can use traditional code to perform the search. So if the decision is true, so yes, we need to do a search. Now we can just do traditional code to run a search tool. And the last thing maybe that we can show here is, let's show the search tool. Also the search tool, same structure, input schema, output schema, and a class with a run and a run async, of course, but also a run.
Yeah. Okay.
And one last thing.
Yeah. So go ahead.
Sorry, maybe one last thing. I chose to use traditional code in this case to pass my output from my agent into my tool. But you could just as well, in some other examples, do this. You can also just say that the output, actually, in fact, I did do that here in the query agent. the query agent's output schema. So the query agent doesn't even have an output schema defined here, because the output schema of the query agent is the input schema to my
Oh, right.
search tool.
Yeah.
And there you go. So you can choose
You
to
can pass it
either,
by.
yes, you can choose to either like do kind of the thing that Crew AI and AutoGen do, like have agents use tools, quote unquote, autonomously, which I guess you could say this is kind of autonomously using a tool. Or you can choose to have the full control over it as a developer and have a bunch of traditional code, maybe do some extra validation, look
Right.
things up in a database. Yeah.
Yeah. Okay, that's amazing. Thank you so much for sharing this. And as you guys can see, this is like really like a Lego blocks. The way you can compose these things is very, it's in fact up to your creativity. It depends how also the use case or the
Yeah.
application that you want to implement. Which brings us to my next question, Kenny. It's about real world applications. So, is there a real world application where atomic agent is already being used?
So yeah, a lot of stuff happened in the past few weeks.
Nice,
So yeah, I mean, I'm a consultant. So one of the things I'm doing right now is being a consultant, and one of my clients, they in fact had this exact thing. So they used LangChain, they built a product, then realized like, yeah, this is a maintenance nightmare. Uh, I was just looking for a project back then. I didn't even really care if it was going to be AI. So, but I said like, oh, here's one of the things that I have done is I have built this framework. They looked at it and they came back to me and they said like, we would actually like to take you into the team to rewrite what we have done and use atomic agents instead. So I'm doing that right now. But we also just last week got the approval to do a proof of concept for a multinational company and software provider for construction.
nice,
So it's a really big company with about 2,000 clients worldwide and about 200 developers internally, and pretty green field. So they don't have any AI stuff yet, but they have a new head of AI that's strategizing what are we going to do in 25 with AI. And so we're going to be building a proof of concept using atomic agents.
nice.
And aside from that, I keep getting emails from people like, "Hey, I've been playing with the framework. I've been using it. Here's a project on GitHub that I made." So yeah,
Getting feedback.
yeah, it's really nice. I didn't expect that at all, really,
Nice. Well,
because really, I just yeah.
first of all, congratulations on your
Thank you.
journey and also your, success professionally. It was expected, in my opinion, because the tool is nicely written, and it's very versatile, very flexible, and so all the qualities of something that is ready to be used or tuned are there, in my opinion. I have a question about how do you see atomic agents evolving in the near future, regardless of
Yeah.
of course, your professional endeavors and.
So yeah, so the core is really lightweight, and I want it to stay that way. Like I mentioned before, I don't want to provide you with 1,000 integrations that will break next week. So the main focus is just getting the core as stable and unchanging as possible. And so far, I've been building stuff with it. It hasn't really changed much in the past weeks, months, really now. I added asynchronous support, stuff like that, but no real changes. So that's the main goal. Other than that, in terms of evolving the framework, it would be getting more tools into the CLI ecosystem. because CLI, again, instead of being a part of the framework, it's more the ideas. You download the tool, kind of as if you would with some modern front-end libraries.
Hmm.
So you take ownership over the tool. It's yours to change. You have the code in your own code base. And in addition, so that's something I still want to add. In addition to tools, I do want to maybe add that you can download agents, but I'm still evaluating what the best way to do that would be, in like to get the most usefulness out of it as a developer.
You mean like pre-made agents, right? Like templates
Yes.
or something. Okay.
Yes, yes,
Yeah, that
yes.
could make
Because I
sense.
do notice that a lot of times, like the query agent pops up back again and again, and the question answering agent, I try to make it as generic as possible so
Right.
that I can reuse it. So stuff like that that I tend to copy paste a lot. I'm thinking
Yeah.
like, oh, it would actually be useful for other
Generalize.
developers to
Yeah.
not have to think about that.
Makes sense. Makes sense.
Yeah.
Kenny, I have one last question for you before I let you go. It's I need to ask you. Take that crystal ball, please. I know you have one under the desk. The question is about AI and the future of AI for humanity. There are always these big questions, especially now that we are approaching the end of the year. I mean, these last years, I can say the plural, have been incredible, of course, for artificial intelligence and the progress that we have seen, of course. What do you think about all this?
Yeah, I think it's great. Of course, a lot of potential benefit, as we have seen and will continue to see. Of course, a lot of potential dangers that we definitely should be aware of. So I would say try to keep it as human centric as possible. Whenever possible, but also in a more practical way, keep it simple. Try not to get too swept up into hype, because a lot of people will try to, how do I say it? Of course,
Abuse
there's
it.
a lot of potential for monetization that's
Yeah.
very valid, but a lot of it will be very grifty.
Yes. I
That's always been
appreciate
the
I appreciate
case.
you say that because this show is known to be the no bullshit show on AI
Yes.
since several years now. So I'm very glad to hear this from. Usually, it's like technical developers who claim this. They are more to the ground, and because they have the real feeling of what these tools can do because they build them. And some other folks are, of course, only using these things, and it might indeed look that they are like magic, but they're not. For a developer, developers do not believe in magic.
Have
So
Have you seen the the promotional posters? There was a company in, I think, San Francisco, and they have some promotional posters of like, hire an agent with us because they won't come into work late, or their camera is never going to be not working today. So on purpose, very dystopian.
yeah,
Of course, you have like that. You have also some people that will be on purpose very utopian. But I think it's dangerous, of course, because to the average person, and even the average technical person, because so much is happening in AI. The most technical people that I know have a very hard time keeping up with everything.
yeah,
And so it's, yeah, we really have to make more of an effort to separate the hype from the reality.
yeah. That's
So
amazing.
yeah,
That's amazing. I will keep doing what I'm doing with this show and try to educate people to the
doing good
non-hyped
work.
version of AI. I hope we do, and we did also today, a decent job. Explaining technical stuff without the hype. But of course, the listeners will tell us. And listeners, please tell us on Apple Podcasts, Spotify, YouTube. We have several channels. Just hit the official website, datascienceatom.com. In the show notes of this episode, you will find, as I mentioned, all the links from Kenny Vaneetvelde, and of course the amazing repository Atomic Agents on GitHub. It's open source, free to collaborate, free to contact him. We live in a free world, Kenny. Thank you so much for being with us today.
Yeah, no problem. Thank you for having me again.
Likewise. Take care.
Yeah. Take care.